Good morning, grade 7 students. Welcome to Mathematics 7, Quarter 1, week number 9. Our lesson for today is all about scientific notation. So at the end of this session, you are able to write numbers in scientific notation and vice versa. And we have the following points to remember. The first one is the definition of scientific notation. It is a special way of writing numbers. It allows us to express a very small or a very large number in compact form. Another one, numbers in scientific notation is written in two parts. The first part is a number part called C. Okay, so we have number part. Any number greater than or equal to 1 but less than 10. A number with base 10 raised to an integer power. So if you will combine these two parts are what we call factors. And we have this format, or you call it a standard form of scientific notation. C is what we call the coefficient. And what does C stands for? It is any number from 1 to 10 but not including 10. Okay, so equal to 1 but less than 10. Since they are factors, then in between of them, we have multiplication. So, C times 10. This is always base of 10 raised to n, and this must be an integer. Okay, I repeat. C is a constant. The value of C is what? Correct. It should be equal to 1 or less than 10. And it is always base of 10. And it is raised to a given power wherein this value of n must be an integer. Okay? You know what integer is. Next, remember, if a number is between 0 and 1, the exponent of base 10 is negative. Okay, so we are referring to the exponent of 10. So if the number is between 0 and 1, the exponent of the base should be negative. But if a number is greater than 1, the exponent of 10 is positive. So do not confuse about the exponent of our base, which is 10. It will be negative if the number is what? Between 0 and 1. And it becomes positive if it is greater than 1. So we have steps in writing decimal numbers into scientific notation. Okay, first step, you are going to identify the initial location of the original decimal point. Okay, so in step number 1 is you identify or you find out or locate the initial location of our decimal point. Okay, initial. So in step number 1, we are referring to initial location. Initial location of our original decimal point. And for number 2, identify the final location or destination of the original decimal point. So step number 1 is we have the initial location, and for step number 2, you are going to identify the final location. Okay, next. Remember that the final location of the original decimal point must be directly to the right of the first non-zero number. Okay, next. Move the original decimal point to its final location. Okay, the value must be greater than or equal to 1 but less than 10. Okay, so from original decimal point to its final location, take note that the value must be greater than or equal to 1 but less than 10. When the decimal is moved towards left, the count for the exponent of base 10 should be positive. So if you will move to the left, your exponent of your base should be positive. When the decimal is moved towards the right, the count for the exponent of base 10 should be negative. So moving to the left, we have positive. Moving to the right, we have negative. Okay, next. Step number 4, multiply it by power of base 10. Okay, so let's have here an example. The given number is 15,000. Take note that 15,000 is greater than 10. So the exponent will be positive. Next. How are we going to, okay, so let us try to follow step number 1. Where is the original location of our decimal point? Right after 0, right? Right after 0. And where should be the final location of decimal point? It should be what? Greater than 0 but less than 10. So this in here, right? Our original location is in this portion, right after the third 0, and the final location or destination of our decimal point should be in between of 1 and 5 to make the number less than, greater than 0 but less than 10. Next. Move the decimal point to the left to create a number between 1 and 10. So move the decimal point. So from here, move how many places to the left? 1, 2, 3, 4. So we have 4 places to the left. Okay, so this will be the location of our final location of decimal point. So remove zeros that are not needed. So these are insignificant digits. So you are going to remove zeros. Okay? Next, we move 4 places. So the power of 10 is 4. So we move 4 places to the left. And if you will move that to the left, your exponent of your base 10 should be positive 4. So the final answer will be 1 and 5 tenths, or we have 1.5 times 10 raised to the 4th power. Okay, why is it 1.5 times 10 raised to the 4th power? Is this correct? Yes, this is correct because our first factor, okay, our first part is greater than 0 but less than 10. So this is correct. This is in between of 0 and 10. Multiplied by our base 10. Okay, 4. How did we get 4? It is taken from the number of moving the decimal point to the left 4 times. So moving to the left is positive. Or in short, if the given number is greater than 10, you expect that your final answer in your exponent should be positive. So we have positive 4. I hope you are following. Another one. How about if we have this? How are we going to read this very small number? Very small number. Okay, so we have the decimal numbers. We have 43 10,000s. The number is a decimal less than 1. That's why it is called small number. So the exponent will be negative. the exponent of our base 10 should be negative. Next, this is the original location, initial location of our decimal point, and the final location or destination should be in between of 4 and 3 in order to meet numbers between 1 and 10. Okay, so you are going to move the decimal point to the right to create a number between 1 and 10. So from here, 1, 2, 3. So we have 3 places going to the right. Going to the right indicates that the exponent is negative. So we have negative 3. Take note, all insignificant digits should be removed. Okay? The 3 zeros are insignificant, so it should be removed. Okay, final answer. 4.3 times 10 raised to negative third power. So we move 3 places, so the power of 10 is 3. But since it is going to the right, and the given number is less than 1, so 3 is negative. Okay, negative 3. Next, how about steps in writing scientific notation into decimal number? So this time our given is the scientific notation and it will be rewrite into a decimal number. Okay, step 1. Move the original decimal point to its final location. So moving the original decimal point to its final location. When the power is positive, okay, the exponent of our base is positive, the decimal must be moved towards right depending on the count for the exponent of base 10. When the power is negative, the decimal must be moved towards left depending on the count for the exponent of base 10. Okay, just like this one. Okay, so let us try to start on this given example. Convert to decimal notation 3.25 times 10 raised to the 9th power. Okay, take note that the exponent is positive, but we have positive exponent. The decimal point, which is here, should be moved 9 times to the right because the exponent is 9 and it is positive. So this will be your hint on how to on how to convert the scientific notation to decimal notation. So from the initial or original location of decimal point, the way of moving the decimal point depends on the given exponent. If it is positive, move to the right. Okay? If it is negative, move to the left. The exponent is 9, so you are going to move 9 times going to the what? Going to the right. Okay. So 3.25. This is the original location. Move to the right. So as you move to the right, you add zeros. Okay? 1. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. This is now the final location of our decimal point. Therefore, it becomes how many? How are we going to read this? 1, 1, 2, 3, first group, 1, 2, 3, second group. So this is hundreds, thousand, okay, million. So we have 3,250,000,000. Okay, 3,250,000,000. So this is what? The value of 3.25 times 10 raised to positive 9th power. So 3,250,000,000. Next, how about if the exponent is negative? Just like 4 times 10 raised to negative 7. Negative exponent indicates that you're going to move the decimal point 7 times to the left. Okay. My question is, where is decimal point in 4? 4 is a whole number and all whole numbers should be. The decimal point is located right after the last digit. So dito, nandito siya. Okay? So 4, the decimal point is right after 4. Kagaya nito. So that is 7 times to the left. So you move the decimal point 7 times going to the left. 1, 2, 3, 4, 5, 6, 7. So we created what? Decimal number. So you always add 0. 0 0.1, 2, 3, 4, 5, 6. So you will add 6 zeros. How are we going to read this? Tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions. So this will read as 4 10 millions. Okay? 4 10 millions. And this is what we call a small number because it is less than 1. Next, in your activity sheets, we have 3 activities to be answered. So in your first activity, you are going to write the following values in decimal to scientific notation. Okay, lahat ng ito from numbers 1 to 10 should be what? It should be written in scientific notation. So we have steps to be followed. Okay, just go over the previous slides. And for activity number 2, expanding notation. Write the following values in scientific notation to decimal notation. So you write all of this in decimal notation. And for the last activity, matching powers, match the values in column A to column B by converting. Let's say, in column A, number 1, you could convert this to decimal notation. Okay, so the choices are located in column B. Okay, so we have decimal notation, convert that to scientific notation, and others. Okay, so we have 3 activities in week number 9. Thank you for watching and have a nice day. Goodbye.